Hello guys, so today we're going to talk about a new way of constructing the probability, which is called a two-way table. Okay, so let's have a look at what is a two-way table and how do we use that. Okay, so a typical learning intention for today, two things. We want to be able to represent events by using this two-way table. Of course, we want to also to use this table to solve the probability related problems. Now, the first bit is easy. What is a two-way table? A two-way table means a table usually 4 by 4, okay? On top of the column, you have an event. For example, people like skateboards and people don't like skateboards. And then next to it, we have the total number of that, okay? And then on the vertical one, we have another event, another criteria. For example, people like snowmobile and people don't like snowmobile. Don't worry what that is. And then the total number, which is at the end. Okay. So the table will basically tell you. So for example, if we see the 80 here, that means people who like skateboards but who also likes the snowmobiles. And then the second number, 25, means people do not like skateboards but they like snowmobiles. Okay, if we add these two up, we will get 105, which is the total of this entire row. Okay, and the similar, if we have a 45 and 10, if we add up, we'll get a 55 as our total. Now, vertical wise is still the same. Now, these two numbers, 80 and 45, will add up to 125. Okay, and all the totals will add up to the column on the bottom right, which is sort of like the final point. Okay, so let's have a look at a typical question that will make a little bit more sense and then more relevant. So let's just say we do a survey on a number of students, okay? And the survey is about first, do you ride a bike? And second, are you a boy or a girl? Okay, so from the information we receive, and then there will be different answers. It can be a boy, it can be a girl, it can be the person ride a bike, it can be person not riding the bike. So if we have a number 7 here, that means there are 7 boys who likes to who ride bikes. And then 4 means there are 4 boys who do not ride bikes. So it's easy to think. All right, so if we want to figure out the total value for that, okay, so we just need to have 7 plus 4, and we'll get 11 in this corner. Okay, likewise, we have 9 girls who ride bikes and then 10 girls who do not ride bikes. So in total, we have 19 girls in total. So adding this up. Now, vertical wise, we can figure out how many people, boys and girls together, rides bicycles. So 7 plus 9 will give us 16. Similarly, when we have these 4 and 10, we add them up, 14. There will be people not riding bike. Now, interestingly, if we add them up, okay, it doesn't matter which way we go. If we add 11 and 19, we get 30. Now, similarly, if we add 16 and 14, we get 30. That's not a coincidence because after all, the number of boys and the girls, the total people we surveyed should be the same. So, if we check the meaning, this block actually means the total boys, and this is the total girls. And the vertical one, that means the total uh, people who rides the bike. And this is like the total people who are not riding bike. I mean, this is a terrible English, but I hope you understand what I'm trying to say. Okay, and this 30 is the absolute total number. That means all people, boys and girls, and all people who ride bikes and who do not ride bikes. Okay, now, we can try to fill in the missing number from the other direction. So, for example, if we have this table, okay, you can pause the video here to think about which number you would put in each block. And when you're ready, and we'll try to go through this all together. All right. So I hope you're ready at this stage. So if we have a look at the information here, now on the first point, it may look a little bit tricky, but if we see there's 100 people, okay, so there are 100 people who drinks water, and then there's 60 people who drinks water and eat pizza. So that means this missing number, okay, If we add up to 60, we will get 100. So therefore, the missing number here should be 40, 40. Okay, now with this 40, we can work vertically. So we have 50 and 40. That means the total number of people who eat hot dogs will be 90. Now, similarly, if we think about, now there are 90 people eat hot dogs, and in total there are 210 people. So that means there are about 120 people. We just use 210 take away 90. We get 120 people who eat pizza. Now, there's 60 here, so that means the missing number here should also be 60 because 120 take away 60 will give us 60. Now the final missing number will be 50 plus 60, which will give us 110. If we read the information, that means then 90 people who eat hot dogs, there are 120 people who eat pizza, 110 people who ordered soda, and 100 people who ordered water. And then if we focus on, for example, this number 50 here, that means the number of people, 50 people who order the soda and hot dogs together. Okay, so in other words, we can just use this table even if there are a couple of numbers missing. Okay, sometimes it's easier to construct a table and fill in the numbers we already know. And as long as you get 4 or 5 numbers in this table, you should be able to work backwards and then try to find all the missing ones in this. Okay, now we just figure out how to use the table, and then we need to understand how do we use that to work out the probability. Okay, back to the example about the boys and girls and a bike and no bike. Okay, so this is already worked out for you. Now, the question is then, what is the probability that if we randomly pick a person and then he is a boy and he actually rides bike? So first of all, if we represent that in the set notion, that's a boy intersect bike, because and, the word and represents as this little intersect symbol. So if we check that, we'll find, okay, the number of boys who rides bike, so it will be this big number that we circled. So that means 7 boys rides bike. Okay, now remember the probability is always a fraction. It's going to be equal to a number, in this case 7, over the total. Now the total, unfortunately, we got to use the absolute total because there are 30 people from our sample. So we just say that is 3 over 30. And you can use the calculator to figure out the decimals around 2.6-ish%. But it's fine to just keep it as a fraction. So 7 over 30 looks perfectly fine. Okay, so that is the probability of boys riding bike. Now you can do the similar things to find the probability of girls riding bike or boys not riding bike. It's the same idea. Use the number in this purple area and divide that by 30. Okay. So the last bit is the extension bit. So if you choose the extension pathway, you will need to understand this bit. But if you choose to follow the core pathway, have a go, and if it doesn't really click in, that's fine. Just leave it and we'll come back to it in year 10. Okay, so basically this is the conditional probability that we're talking about. Okay, the question says, what is the probability that if we randomly pick a boy? Remember, we need to pick from the group of boys, and then the person actually rides bike. Okay, still, we pick a boy who ride a bike, then therefore that's the 7 we get on top of a fraction, no problem at all. But because we randomly pick a boy, so instead of using the 30, we will need to use the 11 because there are only 11 boys in this sample. So we just need to say that is 7 over 11. And no need to simplify, that's already the simplest form. So this probability, also known as the conditional probability, if you're doing the extension pathway, you should be familiar with this word, conditional. That means the probability of the person riding a bike, given that he is a boy, is actually going to be 7 divided by 11. Okay, so I hope at this stage you will be clear of these two things. So a quick recap. We use the two-way table to represent the sample space, especially when there is a yes and no situation or clear cut between boys and girls. Apologies for the gender difference issue, but in math modeling, we try to stick to a simple plan. Now, so if we can have a clear cut as in situation A and not situation A, and situation B, not situation B, then we can construct a two-way table. Two means one and two. Two, that's one way, and that's another way. Okay, two-way table. Now, and then that will help us to understand the details of this number, try to work out the totals, or sometimes we're giving a total to work out backwards. And then using this number to eventually calculate the probability. Now, if you are just working out the probability that you choose a person from the full sample space, if you randomly pick a person, any person from the sample space, we use the green total, which is the corner one, the corner value. Okay, but if we choose, for example, a given context, for example, if we choose a boy, then we need to go to the yellow section and try to look for, okay, boys. That means there are 11 of them. Okay, so depending on which question you get, you might need to use different figures. Okay, I hope that makes sense. And if you do have any questions, please send me a chat message from the teams. Okay, have a good day, guys.